Welcome back to RamZland. Today I want to show you how to grow your own tin crystals using stannous chloride. Check this out. To electrolyze our solution of stannous chloride, we're using 12 molar hydrochloric acid, of course stannous chloride, a little bit of distilled water in this petri dish, a DC power supply, a stir rod, and a dropper. Begin by dissolving just a few crystals of stannous chloride in your petri dish. Stir those crystals until they're completely dissolved, and your water should turn very cloudy. Next, to help your stannous chloride crystals fully dissolve in the water, add a few drops of hydrochloric acid. This will also acidify your solution to make it into an electrolytic solution that'll carry a current. Finally, once your solution is aqueous, connect your anode and cathode to each side of your petri dish and make sure that each connection is submerged in the solution. So this is our petri dish after about 15 minutes, but you can see a lot of tin crystals have grown. Check it out. Isn't that amazing? This is such an interesting example of reduction oxidation through electrolysis. So at the cathode, you have reduction. This is where your solution of stannous chloride is gaining 2 electrons, and it changes from an oxidation state of +2 to 0 as it forms those tin crystals. And then at the anode, you have oxidation, where the stannous chloride interacts with the chloride ions and changes from a +2 oxidation state. As it loses 2 more electrons, it changes to stannous 4 chloride as it changes to a +4 oxidation state. Here's a quick look at the balanced equation for this amazing redox reaction. So through electrolysis, our aqueous solution of stannous 2 chloride dissociates into tin ions and chloride ions, creating the products stannous 4 chloride, which is a precipitate, and of course the tin crystals that you saw that formed at the cathode in this awesome redox reaction. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.